Welcome, sir.
Sir, live, sir.
Okay. Start.
Good evening. Welcome, everyone. Thank you for joining us on today's webinar. The topic is Blockchain Hype in Business World, Introduction and Career Scope, and it will be decoded by our impressive resource personality, Mrs. Alexia Michael from Christ College of Engineering and Technology, Puducherry. I am welcome you all on behalf of Department of Computer Science and Engineering as a part of Nadar Saraswati College of Engineering and Technology, Theni. Now, without further ado, we will turn the time over to call our department head, Mr. C. Pradap, to give a way to garland of welcome address. Sir, over to you, sir.
Yes. Great evening to one and all. Nowadays, e-learning is a new passion, right? First of all, I feel very glad in thanking the management of Team HMU, our secretary, Mr. K.S. Kasi Prabhu, and the joint secretary, Mr. A. Rajkumar, for providing us this wonderful opportunity on successful gathering of this webinar. It's a happiest moment. I welcome my guru, Mrs. A. AUXILIA Michael, for this excellent webinar. Actually, I have started my career under her guidance only, and support helped me to excel in my department so far. Now, coming to the topic, blockchain is becoming the ultimate of technologies nowadays, and this is the right time for all the students to know in depth for it. So, students, please concentrate and learn very easily. And I welcome our Honorable Principal Dr. C. Malay Sundaram sir, and Vice Principals Dr. A. Soleraj sir and Mr. N. Madhavan sir. And then I welcome Mrs. A. Archana, my placement officer also, my professional teachers and the smartest students from all over the state. I welcome all of you. Once again, I welcome you all. Then let's not waste our precious time. Over to you, ma'am.
Okay, thank you very much, Pratap, for your warm welcome. A very good evening to everyone, all the attendees of this webinar. First of all, I would like to thank the management of Nadar Saraswati College of Engineering and Technology, Principal Dr. C. Madalai Sundaram sir, and my student and colleague, he was my student and my colleague, Mr. C. Pratap, head of the Department of Computer Science and Engineering, and all the staff members for giving me this opportunity to share my knowledge on blockchain. And secondly, and I feel immense pleasure to thank each and every one of the participants for taking your time and being here. So I'm not a full expert in blockchain, but I love to learn new things such that I can compete with young minds like you. So I'm going to share what are all the things I learned so far about blockchain, and I hope that this session will help you and to understand what is blockchain, and you will benefit out of it. So without any further delay, let's get into our session. Let me share my screen. I think you're all ready for learning a new technology. Actually, it's not a new technology, but as a student, you're going to learn now only. And most of them will be having some basic knowledge about blockchain, Bitcoin, and so on. Let's have a deep discussion about each and every topic. Just give a second. Let me share my screen. I think the screen is being shared now. Is everyone able to see the screen?
Participants, be patient. The resource people will be connecting you shortly. Participants, thank you for your patience. Kindly be online. The resource people is connecting. Thank you.
Sorry for the trouble here. We have a power cut, so that I could not start the session as scheduled. Now let's see how how we are going to use blockchain in our real world, and what are the introduction, and what are all the concepts behind it. So sorry for the trouble here. We have a power cut, so that I could not start the session as scheduled. Now let's see how we are going to use blockchain in our real world, and what are the introduction, and what are all the concepts behind it. So this is the agenda of our session. We are going to see about the introduction. We have a power cut, so I will not start the session as now. Let's see how we are going to use blockchain in our real world, and what are the introduction, and
AUXILIA, ma'am. Hello.
hello Pratap, கேக்குதா?
Yes, ma'am. Ma'am, YouTube lively இருக்கீங்களா?
YouTubeல
YouTube link இருக்கீங்களா?
YouTube link நானு ஆமா அத க்ளோஸ் பண்ணிடுறேன்.
எஸ் மேம், அத க்ளோஸ் பண்ணிட்டீங்கன்னா கரெக்ட்டா.
ஸ்டார்ட் பண்ணவா பிரதாப்?
எஸ் மேம், ஸ்டார்ட் பண்ணுங்க டைம். மேம்,
Okay. Sorry for that. So, it's the end of the session. So, we are going to discuss about is introduction about the blockchain and what is the concept behind Bitcoin and what is the concept behind digital ledger technology and what is node and what is hashing in blockchain, what is Merkle tree types of blockchain, and what is consensus and mining in blockchain, smart contract applications of blockchain, drawbacks and career. As the name implies, blockchain can be considered as a collection of blocks which contain some information. So, what do you mean by a block? Block is something that holds some information, and it is the ancestor. It was introduced in the year 1991, which is by a group of researchers in order to timestamp the digital documents such that they cannot be backdated or counterfeited. Okay, till 2009 it remains unused, and after that Satoshi Nakamoto utilized the blockchain and created a cryptocurrency called as Bitcoin. And blockchain is a distributed ledger technology that is completely open to everyone. They have an interesting property. Once some data has been recorded in a blockchain, it becomes very difficult to change it. And how does it work? A block contains 3 elements. First element is data. The data that is stored in blockchain depending upon the type of blockchain. For example, if we take a Bitcoin block as example, you'll be storing 3 things, that is from address to address and amount of Bitcoins. The second element is called as hash. You can relate it to a fingerprint. Hash identifies the block and all of its content, and it is unique as fingerprint. Am I audible? So,
Yes.
okay. So this is a digital ledger technology. I repeat again, or I repeat from this. Okay. So this is the second element of hash. A block is called as hash value.
PPT is not visible, ma'am.
PPT is not visible.
Yes,
just
ma'am.
a minute. Today, power is playing in my life, in our session, actually. Is it visible now? Is my screen visible?
Yes, ma'am. Visible.
Okay. Okay. So the second element that is in a block is called as hash. You can relate it to a fingerprint. The hash is used to identify a block and all of its content, and it is unique. And if there is any change in the input, that is a transaction in a block, it changes the entire content of the hash. Am I audible?
Yes, ma'am, audible. Your voice is audible. No problem.
Okay. Okay. So a small change in the hash value will change the change in the block will change the entire hash value, and no one can change it. Okay. So if there is a small change in the input of a block, then the entire hash value gets changed. So this is the main concept behind blockchain, so that if your data will remain secure. And the third element of each block is called as hash of previous block, which is used to create a chain. So that's why we are giving a name called as blockchain. So consider this as example. We have 3 blocks. So block 3 will be holding the hash value of block 2, and block 2 will be holding the hash value of block 1. And this first block is a bit special because it does not point to anything, and this block is called as Genesis block, and the previous hash is 0 only. Okay, and assume that someone is going to tamper, is attempting to tamper the data in block 2. As said earlier, if there is any change in the input of block data, there will be an immediate change in its hash value. As the hash value gets changed, then the data in block 3 and all the following blocks is invalid, because block 3 does not hold the same previous hash value. It is being changed, so that block 2 and block 3 all are declared as invalid node, so that you cannot enter the data in blockchain. For the intruder, it is called as Vadapoche movement, and for blockchain, it is a Yengitieva movement. Okay, and each block header has the following details: timestamp, version, Merkle root, difficulty target, nonce, and previous hash. Timestamp is used to specify at what time the block is being created using which software, and Merkle root is nothing but the hash value of a entire block. We shall discuss in the subsequent slides, and we'll be using 2 terms called as I said earlier, previous hash is used to create a chain of blocks. That's why it is termed as blockchain. This chain is the main advantage, so that it makes the blockchain secure. And we use 2 terms called as difficulty target and nonce that we can discuss while discussing about the topic proof of work. I hope you are clear with how the blocks are created and how they are connected to form a block, and how hash value is used to secure the block data. And regarding Bitcoin was introduced, as I said earlier, it was introduced in the year 2009 by Satoshi Nakamoto. So it's not clear Satoshi Nakamoto is a single person or a group of persons who invented the digital cryptocurrency called as Bitcoin. Bitcoin works in a peer-to-peer network, and it is also called as distributed network. For example, if we want to transfer some amount to anybody, we need an intermediary called as bank. As we mentioned the term distributed network, the major everything is distributed and don't have central control like banks, right? So everything is distributed. If we use the term distributed, then we have 2 major issues. One is trust and one is security, because we cannot trust any data on the internet, and we cannot identify who is handling the database, who is maintaining the database. So blockchain uses a technology called as distributed ledger technology. So let's discuss about what are the differences between the central ledger and distributed ledger. Assume a transaction cycle such that in which Andy is transferring $5 to Bobby, and Bobby is transferring $3 to Derby, and Derby is transferring $1 to Cindy. So now all these transaction details are available in a ledger called as center ledger. Imagine what happens if the center ledger is being hacked or tampered. The complete details with respect to the transaction is totally lost, so that Derby can deny that he didn't receive $3 from Bobby at all. And since there is no proof, we cannot assure that. So in order to overcome this disadvantage, we are going for a technology called as distributed ledger technology, in which instead of saving the transaction details centrally, and each and every participant that are involved in the transaction cycle are provided with a copy of the transaction. So imagine that Andy loses its data, no problem. Andy can get the data from Bobby, and Bobby can get the data from Derby, or either from Bobby or Derby or Cindy. And imagine that if Bobby tries to change the data, Andy, Cindy, and Derby will identify that there is some change in the data transaction data has been done, and which is not encouraged and accepted. So this is the key technology or key advantage in the distributed ledger technology. And this is the backbone of the blockchain concept. And as we say, peer-to-peer network is a collection of nodes that are connected through internet. The nodes can be a computer or a mobile phone or any device which we use to connect to our internet. And we have two types of nodes. One is called as full node and other one is called as partial node. Anything that stores the entire blockchain is called as full node, and we can say a computer that is as a full node, and it also has a additional task, that is whenever you want to add a block into your blockchain, it verifies that particular block. And the next type of node is called as partial node. Imagine a situation that you are willing to implement or download a Bitcoin server in your mobile. So for that, you have to download a particular app. The moment you download that particular app into the mobile, the part of a bit blockchain will be stored in that particular mobile. Since it is storing only the part of the blockchain, it is called as partial node. Okay? And the core concept in blockchain, which makes it revolutionary and unique, is called as hashing. So while considering hashing concept, we will be coming across two terms, important terms. One is called as hash function, another one is called as hash value. So hash function is a mathematical function. We all know about a hash function. So it is a mathematical function which takes input of any arbitrary length and produces output that is of fixed length. Whatever may be the length of the input, it produces a fixed output. Each block has a value, hash value, that is the output of the hash function, which identifies the block, all of its content, and it is unique for each and every block. Let's see how the hash value is being calculated. By saying that the hash function usually accepts input of any arbitrary length, arbitrary in the sense the length can vary from 1 bit to any number of bits, right? So you can give a 50 GB of data as input, and give a name as the input. So in the right side of the slide, you can see that I'm passing my name AUXILIA input the hash function. And I'm using the hashing algorithm that is called as secure hash algorithm 256. So whatever may be the size of the input, the size of the input I'm giving is AUXILIA. Irrespective of the size of the input, the hash function produces an output which is of 256 bits. So from this, we can conclude that based upon the hashing algorithm used by the hash function, the output of a hashing function can vary. If I use, say for example, if I use SHA 512 bits algorithm, then the output will be of length 512 bits. Whatever may be the input, if I give 50 GB of data and I use SHA 256 bit algorithm, it will produce the output of 256. So this is the concept behind hash. And these are the properties of hashing which makes it more effective. The first one is deterministic. No matter how many times you input the same function, the same input, you will be finding the same hash value as the result. Any times you can execute the hashing function for 100 times for the same input without any tired, it will determine the same output for the 100. And the next property is quick computation. The hash function must be able to return the hash value quickly. So if this process is fast, then the system will be more efficient. The third property is pre-image resistance. So this property states that it is infeasible to determine the input data based upon the output hash value. You cannot predict the input from the hash value. It is infeasible because I could say one example. So if I am giving 50 GB of data as input and I am applying SHA-256 algorithm, I will be producing only 256 bits as output. Then remaining bits are lost. So how can you reframe data? So that's why. But you should understand the concept that I am using the term infeasible. I'm not using the term impossible, because the process of guessing the input from the hash value grows exponentially. The only way to guess the thing is brute force. So brute force attack is nothing but you can randomly guess the hash value, and imagine that if you are going to spend each and every second of your day in guessing the hash without sleeping, then you will be doing this work for your rest of your life, and you can never come closer at all. So that's why we are using the term that it is infeasible to find input from the output hash value. Okay. And a small change in the input changes the output. As we discussed in the introduction slide itself, I have told you a small input in a block of data changes the entire hash value. So you cannot tamper the data at all. You can attempt, but there is less chance to tamper the data. And the next property is collision resistant. So collision resistant in the sense, as I said earlier, each hash function will have a unique hash value. Each input has its unique hash value. Two different inputs, if two different inputs result in same hash value, then it is called as hash collision. No hash function is completely collision free, but much like the timeline of brute force attack in guessing the hash values, it is so long, it does not matter. That is, collision can occur, but at rare case only. We cannot say that collision could not happen at all. There is chance of getting collision, but it is rare and it doesn't matter. And the next, as in the introduction slide, let me go to the slide. We have used the term called as Merkle root. And I said that Merkle root is nothing but hash value of a particular block. So now we are going to discuss about how we can get hash value, single hash value for a single block. As we discussed earlier, blockchain has many blocks with previous hash value to form a chain. And each block is a collection of transactions, and transaction can vary from 1 to n. And for each and every transaction, we will be having a hash value. We will be using hash function and we will be finding the hash values. So if we are having 10 transactions, for example, you have to maintain 10 hash values. But each block must have a unique hash value, not hash values. So how you get a single hash value. So you have to combine the hash values of all the 10 transactions into a single hash value. For achieving this single hash value, we are using a concept called as Merkle tree. As the name implies, tree is nothing but a collection of nodes and vertices, and the root, we have root node, child nodes, and leaf node. And all the transactions are at the leaf level, and we will be having we will be gathering the hash values of each and every transaction. So for 10 transactions, we have 10 hash values. In the next step, we have to combine hash value of 1 and 2, which becomes you have to combine H3 and H4 so that you get H3, 4, likewise it goes on. This process is repeated until you get a single hash value. So by combining all the hash values each and every level, we will be getting a single hash value, and this hash value is stored in a root called as Merkle. That is why we didn't use the term hash value. Instead, we have used the term Merkle root. Okay, I think you understand this. Next, we have discussed about types of blockchain. We have 3 types of blockchain framework. One is called as public, private, and consortium.
Hello, ma'am. Ma'am, your voice is breaking, ma'am.
Oh.
Can I play the slide, ma'am? Hello?
Sir, I could not hear you.
Ma'am, shall I play the slides from here, ma'am?
But video will not be there, sir.
Okay, ma'am. So your voice is getting a problem at some situation, ma'am.
Oh, often. Just a sec. Sir, could you hear me now?
Ma'am, still breaking, ma'am. Hello?
Even now it's breaking up.
No, ma'am. No, it's good, ma'am.
It's good now. Okay.
Yes,
I have come to my terrace. Okay.
Okay, ma'am.
Ma'am, again voice is breaking, ma'am.
Again, okay. But my signal is full only here.
No, okay. No, your voice is clear, ma'am.
Okay. Let me start from.
Okay.
Let me fix this, please. So, as the name implies, in public blockchain, anyone can be a part of it, and you can add your own records into the block, and you can act as a miner also. And these blockchains are called as completely centralized. And the next type of blockchain is private blockchain. It is meant specifically for a single company, and no one from outside the company is allowed to contribute. And number of nodes validating a particular blockchain and number of nodes that is getting added to the blockchain is controlled. Am I audible now?
Yes, ma'am.
Okay. And the last type of blockchain is called as consortium blockchain, where a group of people or companies will be getting together to form a blockchain, but it will be controlled by someone or somewhere. Okay. So, but we will be knowing each and every one, and it is called as partially centralized blockchain. It is a combination of traditional as well as decentralized blockchain. So the most important feature of blockchain is called as consensus and mining. By the term consensus, we mean that in some situation, all the nodes that are participating in the decentralized network must come to a conclusion on what the truth is. So in some situations, we will be able to accept what the truth is, and you have to eradicate the fraudulent data. And let me give one example. I think you will be able to see the image here at the right bottom. You can consider in a peer-to-peer decentralized network, many number of nodes will be participating, but each node will not trust any other node because we don't have any central authority here. So no one will be trusting the other. So now the challenge is, how can all these participating nodes agree on what is the true history of transactions? A malicious node or an intruder node can send conflicting transactions to different parts of the network. Let me say one example. So you can see intruder node. Consider his name as Rahul. He's a traitor and he is attempting to send two transactions to two different parts of network, stating that in one transaction he states that Rahul is sending 10 bitcoins to Arun to one part of the network, say for these 3 people or 4 people in the network, and at the same time he is trying to send a another transaction stating that Rahul is attempting to send 10 bitcoins to say for example Karthik to other parts of the network. But actually Rahul is having only 10 bitcoins, so he is trying to double spend his money. So the challenge here is, what algorithm can be used in blockchain network like this to ensure that all nodes should ensure that the transaction stating that Rahul has sent 10 bitcoins to Arun is valid, whereas rejecting the transaction stating that Rahul has sent 10 bitcoins to Karthik. So it has to validate one transaction as valid, and it has to drop the other transaction as invalid. So this can be done if and only if all the nodes participating in the decentralized network comes to that particular agreement. So for that, we use consensus algorithm. Many algorithms are there to come to consensus, that agreement that we are accepting a truth. And most famous among them are proof of work and proof of stake. Let me tell you proof of work first. When you consider proof of work, we'll be coming across an important term called as miner and important term called as computational puzzles. Let me run a video to demonstrate this. Proof of work was developed in the year 1993 by a group of scientists to prevent denial of service attack and other service abuse such as spam on a network by requiring some computation power from the service user. In 2009, Bitcoin introduced an innovative way of proof of work as consensus algorithm, that is to validate the transactions and broadcast new blocks to the blockchain. And from then, it has become a widely used consensus algorithm. And this is the working of this. Miners on a network compete with each other. So how does it work? So we have miners in the decentralized network which compete with each other to solve a computational puzzle. These puzzles are difficult to solve but very easy to verify the correct solution. Once a miner comes with the solution, it will be validated by all the miners in the network, and block 6 is added to the block 5 blocks. So let's see one example. Bitcoin is a see, you could see this. Already imagine that we have 5 blocks in the blockchain. If you want to add the 6th block, the miner must solve the computational puzzle. They must be competing with each other. The one who comes with the solution for the puzzle first will add that 6th node to the blockchain. And that process, the miner who adds the block to the blockchain is called as, he is the one who is responsible for adding the block 6 to the blockchain. So this is done with the help of a value called as nonce. Okay. So miner is the one who is responsible for adding a new block to the blockchain. He must guess a pseudo-random number called as nonce, which should be added with the hash block data and passed as the input to the hash function, and produce the hash function with 4 zeros. So this is called as difficulty target. So once they find the value, they will get a block reward, and after valid nonce is created, the new hash value with 4 zeros, that is block hash, will get updated in all the local blocks, that is from 1 to 5. This is called as proof of work. With the help of proof of work, we can prevent different attacks, because a successful attack will require a lot of computational power and lot of time to do the calculation. So if we say that, so since we are verifying the data, in order to do the calculations, you will be spending lot of resources and lot of time. Okay, so the cost incurred would be greater than the potential rewards for attacking the network. One issue with the proof of work is that mining requires extensive power and computer hardware, and while complicated algorithm calculations guarantee the security of the network, these calculations are not able to be utilized beyond that. So though they have this kind of disadvantage, still it is one of the most popular methods for reaching consensus in blockchain algorithm. And there is in order to overcome the disadvantage of having spending more amount on computational power and electricity, we are going for a concept called as proof of stake. Proof of stake was proposed by a block forum user called as Quantum Mechanic in the year 2011. He states that it is waste of time to have miners compete with each other, because in order to solve the puzzle, that is hashing puzzle or computational puzzle, more amount of computation, more amount of GPUs are required, and it consumes more power. So there is more wastage of resources. Instead, proof of stake uses an election process in which one node is randomly chosen to validate the next block. So, but there is some differences in terminology. Proof of stake has no miners. They have a concept called as validators. Validators will forge or mint the block data, and a validator are not chosen randomly. To become a validator, a node must deposit some stake value, and the stake value can be considered as a security deposit. It is a linear correlation. Say, for example, Bob is investing $100 as stake, and Alice is investing thousands as stake value. Now consider this. Bob is investing $100 as stake, and Alice is investing $1,000 as stake. As from these amount, we can conclude that Alice gets 10 times more chance to become a validator. You can ask me. Only the rich people who is investing more is able to become a validator, and this is not fair. But in reality, it is more fair compared to proof of work. Okay? In proof of work, rich people can enjoy the power of economies at scale. The price they pay for mining equipment and electricity does not go up in a linear fashion. Instead, the more they buy, the better prices they get. So coming back to proof of stake, if a node is chosen to validate the next block, it will verify whether all the transactions in it are valid. If everything checks out, the node signs off the block and adds it to the blockchain. And as a reward, the node receives the fees that are associated with each transaction inside the block. Okay, you can ask me, how can you trust validators on the network? Well, that's where the stake comes in. Validator will lose a part of their stake value if they approve fraudulent transactions, that is fraud transactions. As long as the stake is higher than what the validator gets from the transaction fees, we can trust them that they are doing their work correctly. If not, they will be losing more money than they gain from as their transaction fees. So it becomes a financial motivator and holds up as long as the stake is higher than the sum of all the transactions fee. If a node decided to stop to being a validator, all the stake value and the transaction fee that have accumulated will be given back to them after a certain period of time. So it is not given immediately because there is a chance in a network to find fraudulent blocks. For that, they will be punished so that some amount will be reduced from their stake. So that's why they will not release the stake value immediately. They will be releasing the stake value after some period of time. After all punishments are being given, they are given back with their stake values. And the next important concept in blockchain is smart contract. Can you tell me what is meant by contract? As the name implies, contract is an agreement or set of rules. Say if you many betting apps are there. So in cricket also we will be having online betting. So if India wins, then you will be rewarded with this much amount. If England wins, then you will be you will be punished with some amount that is some amount will be extracted from you. Okay, so these it is nothing but contract is nothing but a tiny program that are written as a part of a transaction and are stored in a blockchain and is executed automatically as a part of blockchain. Imagine that we are planning to I am planning to buy a product from online e-commerce sites. As soon as I say online e-commerce site, the first website that comes into our mind is Amazon, then Flipkart and Snapdeal. Imagine that we have a company called as abc.com. Will you be buying from that? No, I won't buy. Will you be buying? Them, and we don't believe that it is secure. So that's why, could you able to hear me? Am I audible?
Yes, ma'am.
Okay. So imagine that you are trusting that particular ABC company at by any chance, and you are making some order for a product, and you are you are placing the order in prepaid mode. Okay. So imagine that you have paid for the product, but you didn't receive the product in your hand. So you can trust that ABC as a trusted company, but it is not as good in delivering the products. So because it depends upon one more company that is called as XYZ. So XYZ is a company which is responsible for shipping the product to the customer. So this is the trust issue between the three people: customer, ABC company, and XYZ company. So you have to write a smart contract as a part of your transaction. So you have to write a contract in such a way that even if you pay amount to ABC company in prepaid order, the amount will not get credited to that ABC account unless otherwise you receive the product. In turn, ABC should not pay any amount to XYZ until it delivers the product to the customer. So what happens if any one of these things fail? The money will not be credited to either ABC or XYZ. It will be coming back to the customer itself. So there is no third party involved in this. The smart contract itself will solve this issue. And after hearing all these stories, despite of my network problem and everything, you will be getting really confused on how you can implement blockchain in real time. Right? So before getting into the examples, let me have a recap that blockchain is a distributed ledger technology, and that it can be considered as a database in which everyone can add their record, and once added, no changes are allowed to be done. Okay. So this makes the blockchain more secure. And these are the applications. The first application is cryptocurrencies. Let's start with cryptocurrencies. The most popular cryptocurrency is Bitcoin, and it is launched in the year 2009, and it allowed people to directly and it allows people to communicate directly and send data without any central authority like bank. Since then, 1,600 plus bitcoins have cryptocurrencies have come into existence. Now let's look at odometer fraud detection. Have you come across this term? If you want to buy a car online, you will be referring the odometer range, that is mileage of your car. Someone can tamper the data such that the car can appear. So see here. This is called as odometer fraud. it might have run for this much of kilometers, but you can tamper it as it has run only 93,293 kilometers, so that the customer can think that it is a new car and they can pay more than what the car is actually worth. The government tries to counter this by collecting mileage of cars when they get a safety inspection, that is FC, we call it here FC, but that is not enough. So instead, we could replace the regular odometer with smart ones that are connected to internet, such that all the mileage details of each and every car will be stored in the blockchain, such that it creates a secure and digital certificate for each car. So once you decide to buy a car, you can refer that blockchain content, because blockchain content is visible to everyone in case of public blockchain. So no one can tamper the data, and the data remains the same, and everyone could see the resource history, that is vehicles history. So in this way, you can avoid odometer fraud. So in fact, it is already being developed by Bosch IoT Lab, and they are currently testing it on a fleet of 100 cars in Germany and Switzerland. And the next type of application is blockchain can keep track of intellectual properties, patents, and notary. Can you, as soon as I say that, if I come across the term IP or patents, Sivakarthikeyan's film Hero comes to my mind. Have you seen that movie? In that movie, his sister, I think, sister will be designing a project such that she uses seawater to run the vehicle. But she can't claim that it's her own project, because some people have claimed that it has their project, because they have claimed intellectual property or patents of that particular project. This poor girl is not aware of getting the intellectual property and patents. So if you store all your intellectual properties, your findings, patents, and documents on a blockchain, then no one can tamper it or change it or claim that the document is there or project is there, not yours. Okay, so you can defend that it is your project and it is not anyone else. So let me under notary, can you tell me what is the main function of notary? Notary is someone who can confirm the digital signature on legal documents are valid, and you can store all these documents in a stampd.io website in a Bitcoin or Ethereum blockchain. Okay, once you store the data here, you can always prove that you have created the document at certain point of time and it is always yours and not anyone else. It is much like a notary, although right now blockchains are not on the same level as notaries on legal perspective, but it can act as a notary. And the next one is called as digital voting. So in olden days, voting has used paper, and nowadays they are using computers that run proprietary software to count the votes. So if you consider paper, it costs very much. So how you have to print millions of papers to make a poll, whereas in case of, if you consider the electronic gadgets like this, the major issue is the security thing. You can get the computer can be hacked. In recent years, many of the countries are moving again to papers, because they think that electronic votes can be tampered with and they can be influenced by hackers. So you can use blockchain to cast votes and store votes. What happens? Shit. So you can use blockchain instead of paper. You could use blockchain to cast and store votes. Such a system would be very transparent, so that everyone could verify the voting count for themselves, and it would make the hacking of data very difficult one. The Swiss company Agora is working on such a system, and it's going to be completely open source. But there are some challenges. If you want to follow voting system through blockchain, you have to face 3 different challenges. One is called as identity challenge, other one is called as device challenge, other one is called as attack challenge. Okay, so if you must be able to identify the voters without compromising their privacy. Without revealing much data, you should be able to identify the voters alone, not other than that. You should identify from it, so that their privacy should not be affected. If you allow people to vote with their own device or computer or phone, you have to take it into account that those might be infected with malware designed to tamper with the voting process. The system must also consider that it should be able to withstand attacks like denial of service attack, because that could render the whole thing unstable. Besides all these challenges, if you make a voting system on a blockchain, there is no way of tampering the data, and hence digital voting will be a successful one. And the next important field in which you can use blockchain is called as agriculture and food industry. So in agriculture, you will be having the farmers will be dependent upon the third party to sell data, to sell their crops, and more amount of commission amount should be paid for that third party. And for selling the food products also, the same is the concept. So they would use, and they could use this blockchain concept in this way. In food industry, you can track the food products from the moment they are harvested or made to when they end up in the hands of customers. This is because 500 million of people are dying because of foodborne disease, and it is difficult to isolate which food has caused the harm. And blockchain could help us to create a digital certificate for each piece of food, proving where it came from, where it has been. So if a contamination is detected, we can trace it back to its root and instantly notify other people who bought the same batch of bad food. IBM and Walmart, have you come across Walmart in USA? IBM and Walmart are working under such a system. Okay, it allows you to trace the origin of a box of mangoes within 2 seconds, when it takes only 2 weeks or days in a traditional system. If you don't use blockchain, it takes longer time to detect the origin of a box of mangoes, whereas if you use blockchain, you can detect it within few seconds. Okay, and in healthcare also we can use this blockchain concept. Electronic medical records are currently maintained in data centers like cloud, and it is vulnerable to security attacks and can be expensive. A health insurance portability and accountability act, that is called as HIPAA based blockchain based healthcare network, holds a complete history of each patient with multiple granularities. So what are all the data that a doctor can see, and what are all the data that a patient can see, and what are all the data that an insurance person can see, so that the insurance claim is made easy. and payment of hospital fees is made easier, and putting a appointment for a specialty doctor is made easy, and you can track whether he is available, and no one can change your medical record. And these are the applications of blockchain. And these are, as with every technology, we have drawbacks with each and every concept. So blockchain also has its own disadvantages. The first disadvantage is it is complex to understand. So after hearing all the stories like consensus, mining, hashing, proof of work, proof of stake, you'll be literally confused, because it is a bundle of technology, and at the initial stage it is very complex to understand. And the next disadvantage is slow speed. This blockchain technology tells you that they will replace the intermediary like credit cards, debit cards, and banks completely. When we talk about Visa cards, it can handle thousands of Visa credit card or debit card can handle thousands of transactions per second. It's amazing. But blockchain uses proof of work for consensus algorithm. It takes 10 minutes to solve the computational puzzle, and if 5 blocks are there, or 6 blocks are there, 5 blocks are there, if you want to add the 6th block, then it takes, for the 5 on the average of 10 minutes per block, it will be having it will be spending 50 minutes of time in computation, computing the solving the puzzle. So it can handle only 7 to 10 transactions per second. So compare it, where 7 to 10 transactions and where is 1000 transactions. So blockchain is of slow speed, and it many resources are getting wasted, because as we are using many more amount of computation power in terms of GPUs. CPUs are not enough, because we are going to handle n number of transactions from n number of blocks in a peer-to-peer network. So that CPU is not enough. We need GPUs and supercomputing. So imagine that supercomputing has more computation power, and it consumes more electricity. To add a single block into a blockchain, more amount of resources and time is wasted. And the next one is privacy concern. As I said, in the voting application, the voting count, as well as who voted their votes to whom, everything will be publicized. So the privacy of a person is a great question in blockchain. And the last disadvantage is 51% attack. So 51% attack. Imagine that we have 10 nodes in a peer-to-peer network, and only one node is a malicious node. So here comes the majority wins concept. So malicious node is only a one node, and all other 9 nodes are pure nodes, or non-fraud nodes. So they can say that, hey, you are a fraud node, you get out of my network. So automatically the malicious node will be deleted from the network and taken away from the network, and the network will not be hacked. Whereas if we say that there are 6 malicious nodes among 10 nodes, what's the case? This is called as 51% attack. So 6% are malicious node, only 4 are non-malicious node. Hence, the blockchain can be hacked in this case. And the most important part, career path. So if you want to learn, ICICI Bank in India is now using blockchain concept, and Google is going to is already implementing blockchain concept, and every company is on proof of consensus work. If it is accepted, then they will be starting using the blockchain concept. So if as a final year student, or as a technical people, or a professional people, if you want to learn something new, just go for blockchain. because when I research for the career path in blockchain, even I am jealous of becoming a blockchain developer or a blockchain engineer, but in at this age I could not. But if I work for it, then I will definitely become a blockchain engineer. So everything is in your hands. So you have to have a attitude of learning a new concept, and the prerequisites are you should have a little knowledge about cryptography at least, and distributed computing and game theory. Why game theory? Because we are using supercomputing. Supercomputing are widely used in artificial intelligence. Game theory is the only main concept that is used to design many games and to solve some puzzle. Okay, so game theory is also needed. So if you learn blockchain at least to some extent, these are all the scope of career. Okay, you can become a blockchain engineer, you can become an information security analyst, you can become a blockchain developer, you can become a blockchain designer, and the others are of not they won't get that much revenue. But the people like blockchain developer, blockchain engineer, blockchain designer, you can ask me, ma'am, please put the salary in Indian amount. Okay, but most of the people are blockchain is being utilized mostly in America and other countries, and it is booming here now only. So if it is in dollars, US dollars, you can imagine in Indian amount from 1 lakh to, as a starter, you can get from as a starting package as 45K to 1 lakh K per annum. Okay, so it's a huge amount. So I am now very interested to become a blockchain developer or a blockchain engineer or a blockchain designer. As the name blockchain developer indicates, he or she is responsible for building decentralized applications and smart contracts. Smart contracts are nothing but a tiny program that automates all the transactions, and it makes your transaction more effective one. So in US dollars, the salary range from 1,50,000 to 1,75,000. Imagine that you're getting this much amount of salary. So you can achieve this much. You can ask me, as a fresher, you cannot get this much amount of salary, but you'll be having, see, if you get even a salary of about $50, sorry, $50,000, imagine, you can be a king. You can buy whatever, you can become next Bill Gates. Okay, so next, blockchain engineer is responsible for developing blockchain solutions from start to end. How to build a block, and what are all the technologies, and how to create cryptocurrencies, and all these things will be done by the blockchain engineer. And the next one is blockchain designer. So implementation, how to implement hash functions, and how to support a blockchain focused websites, and how to create user interfaces. And the information security analyst is responsible for research on planning security measurements. Other than hashing, you have to use a public cryptography system or asymmetric cryptography system, such that there is no security breach. If there is security breach, then blockchain is of no use. Okay, and the next one is blockchain project manager, who is responsible for organizing, managing, and multiple blockchain projects. As far as I have researched in this quarantine period, I have taught you to the core. So this is all I know about blockchain. Thanks for your patience and listening, and please forgive me. It's a network issue. I can't take the control over the network and power. Okay, I don't have power control. So I am sitting on the terrace with this much sun. Okay, so to utmost level, I have discussed what are all the things that I know about blockchain. So thanks for your patience. Thanks for listening. This whole I didn't see the time also. Thanks for your patience. And if you have any queries, you can ask me.
Good evening, ma'am.
Good evening, sir.
This is Shiva Sharma Karthik, working as assistant professor in our college.
Okay.
Here are some few queries to discuss, ma'am. Shall
Yes,
I
sir.
continue?
Yes, sir. Please.
Okay, ma'am. The first question is from Sweta
Sir,
Ramu.
before that, I am not an expert. As far as I know, I will try to explain
Sure, ma'am. Sure,
and
ma'am.
try
Sure,
to
ma'am.
answer your queries. Okay.
Sure,
Tell
ma'am.
me.
Sure, ma'am. Due to some time constraints, we can discuss only few questions here.
Okay.
Because so many questions are there. Remaining questions we can reply through mail, ma'am.
Mail, yeah.
Okay, ma'am. The first question, tell us what are the ways we can find the hash values.
Okay.
That
So
is
let me go to
from
the.
Sweta Ramu.
Okay, okay. So as I said in the slide explaining the hash value, so we have different kinds of hash algorithms, and popular among them are called as message digest algorithm and secure hash algorithm. See here, you can see the different hashing algorithms. So you have to implement this hashing algorithm as a program, and you have to give the input of any length. Okay, so if you use SHA 256-bit algorithm, the output will be of size 256. That is 64 bytes, right? So if you count patiently, you will be getting 64 bits of data, 64 bytes of data. Okay, so this will be of size 256. If you use SHA 512, then the output length will be of 512. So 512 divided by 4, you calculate that much amount of data will be produced as hash value. So SHA algorithm or message digest algorithm can be used to find the hash value. So it is hashing function is nothing but a program. You have to design it, and input should be given, and it will be produce a fixed length output.
Thank you, ma'am.
Okay, sir.
Next question is from Sandeep.
Yeah.
Is there any research work initiatives can be carried out with the blockchain hype?
Yes, lot of initiatives. You can I could say that we have different versions of MD5 algorithms, MD1 to MD6. So in the last year, I think so, MD5 has been tampered by the attacker. So that's why we have got an algorithm called as MD6. So you can do research in hashing algorithm itself. Not and you can create a consensus, your own consensus algorithm. We have different types of consensus algorithm: proof of work, proof of stake, proof of capability, proof of load, proof of capacity, and everything. And Byzantine fault tolerance algorithm. You can use plenty of multiple signature algorithm. You can use plenty of algorithms to reach to a consensus, to an agreement that a particular transaction is valid. So you can make a research. You can read lot of papers, and now research papers are being, and my research supervisor have written 2 chapters for Taylor and Francis series also. He published 2 chapters regarding blockchain techniques. So you have n number of opportunities. It is a bundle of technology. It is it involves cryptography. It involves artificial intelligence. It involves distributed computing. You can improve the quality of service also. As I said, you have different disadvantages like wastage of resources and slow speed. You can do a research such that the speed can be improved and resource wastage can be minimized. So we have plenty of research openings in blockchain. It's up to you to choose which one to be your field, your choice.
Nice explanation, ma'am. And the next question is, Any solution is there to reduce stack memory and record?
Stack memory, stake, you mean stake? Yeah,
Yeah,
STAKE.
they are mentioning it. Okay, stake. Yeah.
Stake,
They are
proof of
mentioning,
stake.
okay.
Actually, stake is nothing but security deposit. I could explain in Tamil. Okay, you can understand it more better, I think. Shall I use bilingual now?
Okay, ma'am. Sure, ma'am.
ஓகே, செக்யூரிட்டி டெபாசிட்ன்றது எப்போ நம்ம கட்டுவோம் சொல்லுங்க பார்ப்போம். இப்போ காலேஜ் சேர்றோம், காஷன் டெபாசிட்னு கட்டுவோம். ஏன் கட்டுறோம்? சப்போஸ் நடுவில் நம்ம போயிட்டோம் அப்படின்னா அட்லீஸ்ட் காலேஜுக்கு அந்த காஷன் டெபாசிட்டாவது கிடைக்கும், ரைட்டா? அதே மாதிரி தான் இப்போ நம்ம ஒரு வீட்டுக்கு போறோம் அப்படின்னா ஏன் அட்வான்ஸ் கொடுக்குறோம்? ஒரு 10,000 அந்த வீட்டோட வாடகைன்னு வச்சுக்கோங்க. 1 lakh வந்து நம்ம வந்து அட்வான்ஸ் கொடுப்போம். 10 monthsோட இதை வந்து ரெண்டை வந்து நம்ம அட்வான்ஸா கொடுப்போம். ஏன்னா சப்போஸ் ஏதாவது பிரச்சனை வந்துச்சுன்னா கூட நீங்க என்ன பண்ணிடுவீங்க, அந்த அமௌண்ட்டை ரெடியூஸ் பண்ணிடுவீங்க. இப்ப வீடு மாத்திரம், பெயிண்ட், வீடெல்லாம் வீணாக்கிட்டோம், அப்ப வந்து என்ன பண்ணிடுவோம், நம்ம வந்து அதுல இருந்து ரிடக்ட் பண்ணி நமக்கு கொடுப்பாங்க, ரைட்டா? ஸோ அதே மாதிரி தான் ஸ்டேக் அப்படின்றது ஒரு செக்யூரிட்டி டெபாசிட் மாதிரி. யாரு நிறைய வச்சிருக்காங்களோ, இப்போ உங்ககிட்ட நிறைய காசு இருந்ததுன்னு வச்சுக்கோங்க. Imagine that you have huge amount of cryptocurrencies with you and you can invest $1,000 or $1 lakh, even $1 lakh as a stake value. So the validator with highest stake value will be chosen as the proprietary authority to validate the block and add the block to the blockchain. ஸோ இதுல இன்க்ரீஸ் பண்றது நம்ம இஷ்டம் தான். நம்மளோட கேலிபர் எவ்வளோ, நம்மளோட இன்கம் எவ்வளோ, அதுக்கேற்ற மாதிரி இது பண்ணிட்டு நீங்க என்ன பண்ணணும் அப்படின்னா கரெக்டான பிளாக்கை நீங்க வந்து ட்ராக் பண்ணணும், வேலிடேட் பண்ணணும். சப்போஸ் நீங்க இதுல நிறைய ஃப்ராடை வேலிடேட் பண்ணிட்டே இருந்தீங்க அப்படின்னா உங்களோட ஸ்டேக்கோட அமௌண்ட் என்ன ஆகிட்டே இருக்கும், ரெடியூஸ் ஆகிட்டே இருக்கும். ஸோ அப்போ உங்களோட ட்ரஸ்ட் எப்போ போகும் அப்படின்னா ஸ்டேக் வேல்யூ வந்து உங்களோட டிரான்சாக்ஷன் ஃபீ விட கம்மி ஆயிடுச்சுன்னா யூ ஆர் நோ லாங்கர் எலிஜிபிள் டு பி அ வேலிடேட்டர். ஸோ நீங்க இன்க்ரீஸ் பண்றது உங்க இஷ்டம் தான், ஓகேவா? அதை நம்ம எப்படி இன்க்ரீஸ் பண்றது அப்படின்றதெல்லாம் இப்போ அந்த ஸ்டேக் வேல்யூவோட இப்ப நீங்க கேட்கறது இப்படி கூட இருக்கலாம். ஸ்டேக் வேல்யூல நம்ம இன்வெஸ்ட் பண்ணது போக எக்ஸ்ட்ராவா எப்படி நம்ம இன்வெஸ்ட் பண்றது, எக்ஸ்ட்ரா மணியை எப்படி கேதர் பண்றது அப்படின்னா எவ்வளோக்கு அவ்வளோ நீங்க வந்து நியூ பிளாக்ஸை வேலிடேட் பண்றீங்களோ கரெக்டா அவ்வளோ அமௌண்டா, எத்தனை டிரான்சாக்ஷன், 10 டிரான்சாக்ஷன் இருக்குன்னு வச்சுக்கோங்க. 10 டிரான்சாக்ஷனுக்கு, ஒரு டிரான்சாக்ஷனுக்கு ஒரு $50 அப்படின்னா 10 டிரான்சாக்ஷனுக்கு எவ்வளவு வரும், $500. அந்த $500 வந்து உங்களோட ஸ்டேக் வேல்யூவோட ஆட் ஆயிடும், ஓகேவா? அப்படிதான் நீங்க என்ன பண்ணிக்கலாம், ஸ்டேக் வேல்யூவை இன்க்ரீஸ் பண்ணிக்கலாம்.
Okay. Hello.
Yes sir.
Okay, ma'am. Okay. And the next question is from anonymous user.
Okay.
What is block time and how it is defined?
Block time.
Yes sir. Yes ma'am.
Okay. So I am not aware of this term, but I could guess
Block
something.
time, ma'am, they are meaning that how much time it take to block to add to the network.
Okay.
I mean that.
Okay. I have said this earlier also. Imagine that you have 5 blocks in a blockchain already. Okay. So you are attempting to add 6th block to the, as a new block to the blockchain, existing blockchain. So already we have 5 blocks in the blockchain. On average, it takes miner to solve the computation puzzle. It takes 10 minutes to solve the computation puzzle. Okay, so if you take on its average, then 5 into 10, it takes 50 minutes to add a 6th block into the existing blockchain. And it involves more computation power and electricity, because நீங்க வந்து இந்த பிளாக்கை நீங்க ஆட் பண்றதுல என்ன டைம் ஆயிட போகுது, என்ன இதாயிட போகுதுன்னு நீங்க கேட்கலாம். ஒரு பிளாக்ல நீங்க வந்து 10 டிரான்சாக்ஷன் இருந்தா கொஞ்சம் சீக்கிரம் முடிஞ்சிடும். இதே 1000 டிரான்சாக்ஷன் இருந்தா இமேஜின் பண்ணி பாருங்க. அதனோட ஒவ்வொரு ஹேஷ் வேல்யூயும் கண்டுபிடிக்கணும், அதை கம்பைன் பண்ணி மெர்க்கிள் ஹேஷ் கண்டுபிடிக்கணும், நான்ஸ் வேல்யூ கண்டுபிடிக்கணும், கெஸ் பண்ணணும், அந்த நான்ஸ் வேல்யூவையும் பிளாக்கோட ஹேஷையும் கம்பைன் பண்ணணும், அதை வந்து மறுபடி ஒரு ஹேஷ் ஃபங்க்ஷனுக்கு இன்புட்டா கொடுத்து டிஃபிகல்ட்டி டார்கெட், அதாவது எத்தனை நம்பர் ஆஃப் ஜீரோஸ், 4 நம்பர் ஆஃப் ஜீரோஸ் வரணுமா, அது மாதிரிலாம் நீங்க என்ன பண்ணுவீங்கன்னா டிசைட் பண்ணி ஒரு பஸ்ஸில் சால்வ் பண்ணி கொண்டு போய் கொடுக்குற வரைக்கும் என்ன ஆகாதுன்னா அந்த பிளாக் ஆட் ஆகாது. அந்த பஸ்ஸில் சால்வ் பண்ணி வர ஆன்சரை மீதி இருக்கவங்களும் என்ன பண்ணணும், வெரிஃபை பண்ணணும். ஸோ ஆன் அன் ஆவரேஜ் இட் மே டேக் 50 minutes to add a 6th block into the existing blockchain.
Okay. Here is the final question, ma'am.
Yes, sir.
Is blockchain algorithms can be used in wireless sensor networks? The question is from MEM Kumar.
Okay. Actually, I am unaware of wireless sensor networks. I am not in deep. I'm not having any deep knowledge in wireless sensor networks. But anything can use blockchain concept so that their data can be stored safely. Okay. So using hash algorithm, you can defend that your data is free from getting counterfeited. Okay. So any industry or any network can adopt this blockchain technology if it is distributed. If it is centrally controlled, you cannot use it. If it is distributed, you can definitely use the blockchain.
Okay.
Okay,
ma'am. Thank you, ma'am. Thank you for your clear explanations. Participants, if you are interested to ask your queries further, better you can mail to us. Remaining questions will be later.
I could send. I could show you my mail ID. Let me stop sharing my screen.
Sure, ma'am.
Okay.
Okay.
And my mail ID is auxilia.michael, AUXILIA. I will send it in the chat box.
Okay, ma'am.
You can refer it. So my official ID is AUXILIA Michael at christset.edu. Okay. This is one of my mail ID, and my personal ID is auxilia.michael@gmail.com.
Have you sharing your screen, ma'am?
No, I'm sending us a chat message.
Chat box. Okay.
Yeah. Okay. You are free to ask any doubts. If I am aware of your doubts, I will be answering it.
Okay, ma'am. Thank you, ma'am. Ma'am, Ambia, ma'am, it's over to you, ma'am. Ambika, ma'am.
Yes, sir.
Over to you.
Okay, sir. Thanks for the valuable webinar, ma'am. It's time for the vote of thanks, and it will be delivered by Mr. R. Uday Kumar, the coordinator of this webinar. Welcome, sir.
Uday Kumar, sir. Okay. You're on screen, sir.
Yes, sir. Thank you for your session, ma'am. In your busy schedule and due to some technical issues, the time was extended till 30 minutes, and then I hereby thank the management of TMHNU and our principal, Dr. C. Madali Sundaram, and our head of the department, Pratap sir, and the faculty members, and not the least, the participants from various states have participated here, and thankful to you too, ma'am.
Thank you, sir.
Thank you.
My pleasure.
Thank you, ma'am.
Thank you, ma'am.
Okay, Pratap. Let's see
Okay,
later.
ma'am.
Thank you so much
Okay,
for
ma'am.
the opportunity.
Thank you, ma'am.
Bye. Bye, Ambika ma'am.
Thank you.
Thank you.
Ma'am. Thank you, ma'am.
Thank you, Arun sir. Bye. Thank you, everyone.